A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. This is part 2 of our week 4 lecture. From the last lecture, we actually continuing here with some examples. I think we have 2 examples here, but these examples are quite long, where I will try to cover as much as I can, whatever. If not everything covered, then maybe we can have a discussion later on in our tutorials, and maybe I can give you another session or something like that. However, this is not so difficult. So let's see here what is given. This is one example actually from Sadiku book. Sadiku is a point is given here, actually here, so we know this point is from rectangular, I think, because these all are values. Okay, there is no angle involved here, so the rectangular is given here. And if we see the vector also, a vector, so point P and a vector is given. So where a vector is y and x involving ax and ay. So this is also from rectangle coordinate system. So now we know that this is rectangle coordinate system. So they are asking that evaluate them in the Cartesian A at P, evaluate A at P in Cartesian cylinder and spherical system. Remember, A at P. So to do so, actually we will learn many things, that how to convert a point, represent a point in different coordinate system, also how to represent a vector in different coordinate system. That's what we have learned in our previous lectures theoretically. So we start now. We have given P is equal to x, y and z. It means x is equal to -2, y is equal to y is equal to 6 and z equal to 3. Now we find out our elements for our cylindrical and spherical coordinate system. For cylindrical, we know that we need to find out rho and phi, and for spherical systems we need to find out r, phi and theta. Okay, so we go for our rho first. So rho is equal to, we know that root over x square plus y square. Since we know what is x and what is y, we find out like this. Z, we know z is z, there is no change. And phi, we know that tan inverse y by x. So y is equal to 6, x equal to -2, which is 108.43 in degrees. This, remember, this one can either be in degrees, also can be in radians involving pi or not involving pi. Okay, so we have now rho, phi and z value. Now we need to find out r and theta. So we know what is r. R means x square plus y square plus z square root over. So we put this value and we got 7. And then theta is equal to root over of rho divided by z actually. So rho means actually x square plus y square square root. So we use this value, root over 40 divided by 3. So we got 64.62 degree. So now see how we represent this one. So if we have a Cartesian or rectangular coordinate system, then we convert it to a cylindrical coordinate system, and this is a spherical coordinate system. Now I told you guys already that if it's a cylindrical coordinate system, then there will be one angle. See here, there's one angle here. And I told you also that if there is a spherical coordinate system, then there will be 2 angles. See, so there are 2 angles. So this is rectangular or Cartesian, this is cylindrical, and this is spherical. So now this is given, so this is vector, this vector is given, so we are representing this vector at P. So for P, if we pass this coordinates into this one, so y is equal to 6 and x plus z is here, so x plus z means 1. So we put these values here, so we put 2 is equal to minus 2 is equal to here, we put 6 is equal to here, and we put 3 is equal to here, so we get this. So in the Cartesian system, A at point P is this one. So one representation has been done, so the Cartesian is done. Now we move on to the cylindrical and spherical system. So first we will move to cylindrical system. Okay, I will not go here because you can use let's go back here. So from rectangular to cylindrical we use this one, right? So there we will use this one. So we have rectangular already, ax, ay and az we know already. So we will find out a rho, a phi and a z. So here we come here. So this is formula, but we know what is this is given, right? This is given. So y is equal to ax is equal to y because it's with small ax, so ax is equal to y, and ay, since this is with ay, so this is big ay, this is the value of the vector, and this is the unit vector, so we don't take this one, we take this as a big A y here. So x plus z is a y. Since there is no az component, means big Az is 0. So now we replace our ax, ay and az here. So ax is equal to y, ay is equal to x plus z, and az is equal to 0. As simple as that. We multiply this with this here, plus we multiply this with this is here, and 0 multiplied with 0 is equal to 0, so you don't write it down. Similarly, to find a phi, we multiply this one with this, plus this one with this, and this one with this, we get this. And as usual, 0 multiplied with this, 0 multiplied with this, and 0 multiplied with this means all are 0. So we don't have any az component for the cylindrical coordinate system. This is very important. Now since we got all of our values, all those values that we got, a rho, a phi and az, but y, x and z needed to be converted also, because all these elements need to be converted to rho or phi. So x we know is equal to rho cos phi, and y equal to rho sin phi. So we put it here, and then this becomes a rho, the first one, this one. So this one a rho, the whole thing we replace with rho cos phi and rho sin phi, x and y. Since z, there is z value, still there is a z element here, because this is a cylindrical system, so z will be there, no problem, but x, y cannot be here. So we replace x, y with this one, and then this is the representation of this vector. This is a rectangular vector. We convert it already to cylindrical one. However, if they don't ask you to find it in a given point, then after this is done, if there is no point is given. But if the point is given, that at P you need to find out how. At P we know here, from here, that rho is equal to 6.32 and phi is equal to 100 and something, and z is equal to 3. Then we replace this is the equation, right? So a is equal to this, right? So we put rho is equal to root over 40. So but we directly doesn't know what is 10, but we can do one thing, is we can directly put phi here, or let's say they have done it like this. It can be done like this. Since you know tan, you know cos and sine also. If you find difficulty to find tan or something from tan, if you find it is difficult to sort out what is cos and sine, you can put directly phi here also, phi and then multiply, no problem. Or if you can find, then it will be somewhat like this. So the phi value is known, so cos phi and sine phi can be dealt with either way. You directly put, or you find directly cos and sine, no problem. From 10, it's up to you how you're gonna do it, but you need to replace those values here for this vector at P point. So then you get this one. So the cylindrical representation has been done. Now we move on to spherical representation here. So we use again from the table, we use these values, this formula, where we already know that ax is equal to y, ay is equal to x plus z, and az equal to 0, and so on and so forth. We multiply again, and then we get this. In the same process, we need to substitute this whole thing, x equal to y, here. Check here. Remember this one, that you need to substitute x, y, and z into r, theta, and phi. There cannot be any x, y, or z element here. No, cannot, because the cylindrical coordinate doesn't have any x, y, and z. So all the x, y, and z needed to be converted to r, phi, and theta. Remember this thing. Always remember this thing. So after we substitute everything here, we got these values. So up till this point, if there is no point is given, your answer is already done. But here the point is given. So at P, we know r is equal to 7 because we find it here. R is equal to 7, and then theta is equal to 64.62. They have done it a little differently, but you can directly put phi and theta values here also, and then you can directly calculate these values, and then you get somewhat like this. So this is the representation, and the representation has been done. What concludes this example. Now we go to example 2. Now if you have any trouble equating this one or understanding this one, of course I'm here. I will be later assisting you how to do it. But however, I believe that it's more or less clear for you, but you need to practice. You need to practice a lot. Here there is another example where another vector is given, where ax and az components are given here. Only vector, there is no point given so far, where it asks that transform a vector into cylindrical and spherical. What we have done already, and this transform this rectangular coordinate point into cylindrical, that what we have done also, and evaluate the vector a at P in rectangular, cylindrical, and spherical coordinates. That we already have done it, but I have also solved this one here. This is also from book Sadiku actually, so it can be, in the solution is there actually. So but I want you to understand this one by yourself. It's a little complex, but usually in the exams these things will come, this type of things will come for sure, 100% sure. But it will not be exactly like this, but it will come in a more simpler, or maybe, I'm afraid, maybe if it's you are unlucky, then it will be more complex form. So the answer is given here. I would really like you to go through the answer and try to understand how we have done it. The procedure is same as the example 1. So it's it's done. The C part also there, it can be dealt with, and for you to understand this one,